For those who are joining us from the MENA region. Thank you for joining us today. Today we are starting our first academic seminar with the J-MENA project in cooperation with the Japanese universities. I'm Khawla from the J-MENA project, and today I would be cooperating with OSAMA Sensei from Kyushu University, giving us a lecture about water treatment and bioenergy generation. So at the beginning, I would like to give a brief presentation about the J-MENA project on behalf of Oki-sensei and Serezawa-san, and then we move to Osama-sensei to introduce the WEEL research field. So please, we would like to thank you again and mute your microphone to avoid any inconvenience during our live session. So first, I'd like to share the screen. And now, as you may know, the J-MENA, it stands for Japan, Middle East, North Africa. So the project aims to increase the number of students coming from the MENA area to join the Japanese universities and follow their research career. So the J-MENA project is located currently at Kyushu University. Here you can see its campus is in Fukuoka City, and the project itself does not represent only Kyushu University, but it's cooperating with more than 29 Japanese universities like the University of Tokyo, Kyoto University, Osaka University, etc. And we are working hard on making the list more and more interesting for those who are interested to join the Japanese universities. One of the main activities of the J-MENA project is to hold educational event, either online or physical educational event. We are glad to share that one of the successful events were held recently in Jordan, also in Egypt. So we would like to make the idea popular among all students that it's possible to study in Japan, it's possible to get the scholarship, for example, the MEC scholarship, and apply successfully and get your chance to join the Japanese universities. Soon, starting from September, we are going to start the online education fair. Many representatives of the Japanese universities will represent and let you know more about the application requirements, how to apply, and how to get ready for your future in Japan. So do not hesitate to contact us for further support. You can join our YouTube channel to check the successful stories of the successful MEC scholars. So they are sharing here how they got the scholarship, how they applied, and how they are living in Japan from a student perspective. So also you can join us on Facebook, on Instagram, and for further support, don't hesitate to contact us via email as well. So here is a brief presentation of the J-MENA. I would like to stop here, and I would like to thank again Osama Sensei from Kyushu University for his time and cooperation. And Osama Sensei, onegai shimasu. Onegai shimasu.
Paula-san, can you see my slide now again?
Yes, perfect, Sensei. Yes.
Okay, thank you. So again, my name is OSAMA ELJAMAL. I'm an associate professor of environmental engineering and the head of the Water and Environmental Engineering Laboratory, WEEL, which is belong to the Interdisciplinary Graduate School of Engineering Science, IGSES, of Kyushu University, Japan. Of course, today I will talk about the role of nanotechnology in water treatment and renewable bioenergy. But the outline of my presentation, I will do brief introduction about Kyushu University, then about our school, my laboratory, and nanotechnology application, and then nanoparticle more specific, then more specific iron nanoparticles, and some application of those nanoparticles in our, environmental research. Kyushu University, let me start. Maybe all of you know Japan, but maybe some of you didn't know in details something about Japanese university. Japan has 8 major national universities, starting from the north, like Hokkaido University in the cold part of Japan, Tohoku University, University of Tokyo, Tokyo Institute of Technology, Nagoya University, Kyoto University, Osaka University, and Kyushu University, which located in the west part of Japan in Kyushu Island and exactly in Fukuoka City. And this university, Kyushu University, was established in 1911, more than 100 years, as a fourth imperial university in Japan. Actually, we have about 12,000 undergraduate student and 7,000 graduate or postgraduate student, master and doctoral course, and about 2,400 faculty members, professors, associate professors, and 3,300 administrative supporting the student and the faculty member for research and teaching. So actually, the ratio between the students and the professor in Fukuoka on Kyushu University is very nice, almost one teacher for 8 students. So there's opportunity for students to get advice and work directly with the teachers. So in Kyushu University, we have several graduate schools for the postgraduate, like the humanity, mathematics, health science, engineering, and so on. And those graduate schools almost cover all postgraduate study for master and doctoral course, and almost all research point or topic under those uh, branches. And one of them is Interdisciplinary Graduate School of Engineering Science, IGSES or XS, which we are belong, or my team belong to this school. X is actually located in the Chikushi campus. We have our own campus separately from Kyushu University. So Kyushu University has several campus, including the big one, Ito campus, but this is Chikushi campus is specified for the Faculty of Engineering Science and exists. In this campus, we have also Institute for Material Chemistry and Engineering, Research Institute for Applied Mechanics, and Global Innovation Center. Those three centers and institutes supporting our research and school activities. Actually, the campus is located very close to the downtown. So from Hakata Station, the downtown of Fukuoka City, 10 minutes by train. It's really very convenient. And even from the airport, Fukuoka International Airport, 5 minutes by subway to Hakata, then 10 minutes to Onoyo Station. Then we can arrive to the Shikoshi campus within 2 minutes. And in this campus, under the exits, we have 65 laboratories. That means 65 research team. Those 65 research team covering the material energy environment. So almost any research topic or points under the material energy environment will be covered with these 65 laboratories. And inside the campus, we have two beautiful environment. In spring, we have the sakura flowers. Winter, we can get the ice or snow. And in the summer, we have the same green with different color green. And then again, in the autumn, we have several, colors. This is located in Fukuoka City. And this is the view of Fukuoka City from the seaside. Also, Kyushu University very friendly with the environment, the international, and they create very nice and friendly environment for everybody, including even the food. They offer the food for vegetarian, international food, halal food, vegan food, and even for Muslim students, they offer place in Chikushi campus as well other campus to perform prayer in the inside the university. And we have got also the Fukuoka Mosque close to the downtown, which is also very important for the Muslim student, and they can conduct and run several activities in that mosque. Inside the Shikoshi campus, we have KISA, which Kyushu University exists International Student Associations, which has 40 students from 40 countries. They conduct or they run several activities, and they visit several places around the Kyushu Island. and most of the international students involved and join in this activity. Back again to my lab, which is Water and Environmental Engineering Laboratory. This is the name of the lab, and we summarized as WEEL. In the WEEL here, we work in two main topics or research theme. The first one, environmental remediation. More specifically, we focus in the water treatment. In another hand, we work with renewable energy, more specific renewable bioenergy. So in this research, we use the techniques, the concept from the science and engineering to improve the both side, the remediation or treatment, and also bioenergy generation, as well as we focus more in this part on the nanotechnology to use the benefit and I mean the advantage of nanotechnology to improve the efficiency of the treatment and energy generation. So why we focus in the water? Because all of us know the water is the source of life. We cannot survive without water, and the demand increasing because population, industry, agriculture activities all need more water to continue and to be sustainable. And the most serious problem come from the wastewater, which is discharged or released to our surface water without pre-treatment. And United Nations World Health Organization in 2019 reported that 144 million people drinking contaminated water, and this is very high risky in their health. So water treatment is not optional. This is urgent and required, should be done to protect our environment as well as to overcome the water deficit and the problem. So in the WEEL, as I mentioned, we focus on the nanotechnology advantages and benefit from the nanotechnology to treat the water and improve the efficiency of the treatment system. In the other hand, we also focus in the energy because energy also important thing for life sustainability. And we know due to the increasing population, industry, agriculture, also the shortage in non-renewable energy, we need to think about other alternative for energy. In other side, the most energy comes nowadays from fossil fuel, oil and gas, and that's also source for the pollution, atmosphere pollution or pollution, air pollution. So in this point, we think the renewable energy is an option and very nice option, like solar energy, wind energy, geothermal energy, biomass energy, and so on. So in the WEEL also we focus in the bioenergy generation as one of the alternative of renewable energy, and we got the benefit from nanotechnology to improve this generation. So nanotechnology itself, is it something when we talk about nanotechnology mean we work with something with nanoscale size? That means very small size comparing with the, I mean the meter or micrometers. So if you look to this scale, so this scale starting from the meter to the angstrom size, and if you look to this part like 100 micrometer or less, we can recognize the material within this size by our eyes. But if we go less like 10 micrometer, 1 micrometer, we need some devices like light microscope to investigate the things within this size. But if we go less like 100 nanometer or 1 nanometers or less, a light microscope will not be helpful. So we need special device like electron microscope to investigate the size of the material with nano size like virus size or DNA size. So this is the point about, I mean, the size. We are in this region here, very small region to deal with the material. And the question is, the nanotechnology really new thing or something old? The answer, nanotechnology is not new idea. So it's very, I mean, long used by humans, but maybe they didn't recognize that they use nanotechnology. For example, the Egyptian used the ink which contained some nanoparticles long time ago, maybe more than 5,000 years. And also in European, they use the nanoparticles of gold and silver to paint the glass and ceramic, maybe in the 10th century. So they used technology before. And in the 13th century, Damascus rod, which contained some carbon nanotube and nanowires, was fabricated long time also. But of course, they didn't know they deal with nanotechnology in that time. But the first time the nanotechnology idea was rising up by the Feynman from the United States. He is physics, and he talked about the price for the working motor, which is less than 1 by 64 inches, very small thing, workable thing. So the idea starts, the people start to think about workable with small size. But the nanotechnology term itself, first time used by the Taniguchi, Professor Taniguchi from Japan in 1947, and he worked in the material science. And since that time, many researchers and many, academic have more interest to know more and more about nanotechnology and nanomaterials. And the point about nanomaterials, when we talk about nanoscale, we have to remember this material will not be behave like bulk scale. They will not follow the physical law which already known. So there is different behavior of those material because this is too small scale, atom scale. So the behavior between the atom is different comparing with the bulk scale. For example, the gold change, the color also change. For color of the gold, for example, if you look to this picture, when we see the bulk scale of the gold is gold color. But if we fabricate the gold within the nano bar size, like 100 nanometers, we can see the color is blue, completely different. And if we go smaller to 20 nanometers, it will be red. So the color change, so physical and properties also change. Boiling temperature as will change. The gravity force will be neglected because the dominant force will be the electromagnetic force between those nanomaterials, the atoms of nanomaterials, not the gravity force. The most important thing when we talk about nanomaterial, we mean something between 1 to 100 nanometer in size. So if we fabricate something within this range, we can consider is a nanomaterials. And the most, benefit come from this material is the surface area. So nanomaterial has extremely small size, but high surface area to the volume ratio. You can imagine simple example like this. This cube is 4 centimeter, and the surface area of this cube is 96 centimeter. If we do simple action, cut this cube vertically in once and horizontally in another way, then we will duplicate the surface area almost 192. So then if we increase the cutting of this cube, we will increase the surface area. We got a huge surface area with the same volume, the same mass of material. So surface area of very important in this point, but also the reactivity of surface itself playing very important role in the water treatment and energy. So nanoparticles actually has several applications in different fields, including the medical, energy, material. For example, in the medical, they use the nanoparticles because nanoparticle size is less than 100 nanometer, and it can be used to deliver the drug in our body faster and more efficient, comparing with the red blood. You know, the red blood has responsibility to deliver the drug inside the body, and the red blood cell is 7,000 nanometers. So you can imagine this is 7,000 nanometer, and we can use another size which is less than 100 nanometer. Then the diffusions and the transport will be faster and more efficient. And in this field, we also Just this is one example of the application about the groundwater treatment. So if we have water and underground water, or we call it groundwater, and that water contaminated, then we can inject the nanoparticle using the injection well, and we can create a zone like reactive treatment zone. Then the water can pass through this reactive zone, and then we get treated groundwater after that zone. So this is simple example can be used based on the nanoparticles. So as I mentioned, this is nanoparticles, and we can fabricate or synthesize nanoparticle by different ways. From the top, I mean, down approach, we start from the bulk material, solid state of the material, we can form the powder and nanoparticles. This is mechanical physical process which can use to fabricate the nanoparticles. But in other side, we can start from the bottom up, which is from the atom molecular size. We form their clusters and the nanoparticle. And this is starting as a liquid or gas status. And this is basically chemical, I mean, technique. And actually in my lab, we use this approach, bottom-up approach or chemical reaction approach. So in this regard, we need to characterize those nanoparticles, and we want to know their, I mean, characterization, physical and chemical properties. So we use the X-ray diffractometers, XRD, to investigate the composition and the crystallinity of those material, as well as we can use the FTIR to investigate the elemental bounds on the surface of those material. We can also use the laser particle size analyzer to determine the particle size of this material, which is nano size. And here also we can use the transmission electron microscope to see those material and to investigate the morphology and properties of this material, as well as the SIM scanning microscopy can be used also to investigate the surface structure of those material. PET surface area can be used also to determine the surface area of those nanoparticles, which is very important, as we mentioned before, to conduct the treatment process. So moving to the specific one, which is iron nanoparticle. Iron, here we talk about the iron. Iron, you know, is Fe, or steel, some people call. So iron is one of the nanoparticles, very effective nanoparticles, and is friendly to the environment. And usually the nanoparticle has this structure. The core of nanoparticles contain the Fe, and Fe will be deal as or act as electron source. That electron will be used to reduce the contaminant from the water, and also the shell of the particle which contain the ferrous or ferric or the oxides status of oxygen, which can be a site for adsorption for the contaminants. And this is the picture of the nanoparticles, iron nanoparticles, and this is the TIM image showing the particle shape and the behavior of this particle to each others. So why the iron, or we call it sometimes nanoscale zero valent iron? Because it's cheap and abundant. The iron is, you know, the fourth element exists in our earth, and it's strong reductant and easy to separate from the water by magnetic field after a treatment. And we can, I mean, decrease the time and the cost of the cleaning using those particles. So how to synthesize this particle? Actually, we need source of iron, like here ferric chloride, and we need reductant like sodium borohydride, and we add the sodium borohydride to the ferric chloride under specific conditions. We control all the condition here, and following this chemical reaction, we can get the Fe0, which Fe in zero, or I mean in nanoscale size. If we control the environment and the condition and the parameter, we can go the nano size. Otherwise, it's difficult. This is the X-ray of the if the nanoparticles, which show the peak here is 44.82 theta, which mention or which confirm all the material here is Fe. There is no other material exist. And here showing the TIM image with 20 nanometer, how the particles forming with the spherical shape. And here is bimetals, and here coated NZVI or coated iron. So I will talk about some example or application for this nanomaterials or nanoparticles. First of all, we investigate the tenses of nanomaterial or the iron nanoparticles, and we control all the parameters to get high surface area, small particle size, and improve the characterization of those nano iron. And we optimizing the tenses of the material, then we get higher reactivity and minimizing the cost of those material. The results show that those material, after optimization, increase the removal efficiency of nitrate 27%, more than the base one, and also 90.5 the removal efficiency of phosphorus has been increased. And at the same time, we reduce the cost about 56%. So this is good achievement. We improve the efficiency and reducing the cost. Actually, this information, if you're interested to more details, you can visit the Journal of Environmental Engineering, and we published this information in 2018, which is good journal in our field. Also, we improve the iron nanoparticle by doping the second metal to increase the efficiency. And in this study, we investigate the iron nanoparticle along with the copper as a second metal on the surface of the iron. And we can see the iron has ability to remove the phosphorus from the water about 50%, but with the second metal as a bimetal, 100% removal. And this information also published in 2016 with the journal, Chemical Engineering Journal, which also very high impacted journal in this field. After that, we also apply the concept of nanoparticle to the groundwater treatment by simulating the permeable reactive barriers. So we can put the nanomaterial here, and the groundwater can pass from this nano reactive barrier. We can get the treated groundwater. In the lab, we design this system, column system, and we investigate different scenario to introduce the iron nanoparticle to remove the phosphorus from the water. We get very, attractive result, and high adsorption is almost the high absorption capacity, 203 milligram per gram of phosphorus was absorbed. And we explain the mechanisms in details, but you can find all those details in the Journal of Molecular Liquid, which published in 2020 with the High Impact Factor Journal. And actually this work is done with a collaboration with the University of Oxford, specifically with Professor Ian Thomas from the Department of Engineering Science at the University of Oxford. So later on, we also fabricate another material here, which is iron nanoparticles with zeolite. So why we use this material? Because we plan to remove the cesium from the water, and cesium is radioactive elements. It's really released into Fukushima area after the disaster, tsunami disaster in 2011. And we try to remove those nanomaterial, or the radioactive material, using nanomaterial or nanoparticle along with zeolite. So we investigate the different scenarios, the dosage and the pH and the temperature, and we realize that this material can be able to remove 100% the cesium from the surface water using this continuous removal system, starting from the source of the contaminated water in the reactor, and then we have separator or settler to remove the material and get the clean water from this side, and then another aeration tank to confirm there is no particle here, and then finally sand filter. Then we can get 100% treatment from the end of this system. This information also published at the Journal of Collapse and Interface Science in 2020. Another project we work in the antibiotics, which is here cyclofloxacin, one of the antibiotics, because antibiotics now exist in most of the surface water, and that's create a lot of the health problem due to the antibiotic resistant gene. So some bacteria has strong resistance to antibiotic due to this situation. So we investigate the best coating ratio. We use the iron nanoparticle coated by magnesium hydroxide, and we investigate several coating ratio and several dosage, and we find the 96% or more from the antibiotic can be removed using this material. And this information also published again in the Journal of Collapse and Interface Science with high impact factor. Then we move to the interaction between those nanoparticles and the possibility of methane generation through the anaerobic digestion system. So we generate, or we design the anaerobic digestion system, and we supply the activated slide to this system. Then we introduce the nanoparticle, different type of nanoparticles like iron nanoparticle or the iron coated nanoparticle. And in this study, we found that the nanoparticle contribute significantly to the improvement of methane generation, and about 120% increasing more than the regular methods. And this is good achievement as well. We already published this information in the Renewable and Sustainable Energy Review, which is high impact journal in our field, and this is published in 2021. So before ending my lecture, just I will let you know important information. We also conduct, or we organize every year in October, the International Exchange and Innovation Conference on Engineering and Science. And this year, the conference will be on 20 and 21 October, and the deadline to submit paper will be July 31st. And this conference completely free registration. There is no thing have to, to pay from the participant, because this conference, sponsored by our lab and Kyushu University. So if you're interested, you can join this conference in 20 and 21 as just you can attend as a participant, or you can submit paper. More information can be found in this link, conference website here, and you can find all the details about this conference. Finally, my lab, as I mentioned, water and environmental engineering laboratory, and you can find more details about the WEEL at the WEEL website. Just you can visit this website, or probably you can scan this code, and then you can get all the information about our research activities and so on. Thank you so much for your kind attention. And if you have a question, please.
So thank you very much, OSAMA Sensei, for the beautiful presentation. I think everyone now is having a good idea about wastewater treatment, nanotechnology, etc. So if anyone is having questions, do not hesitate to ask. OSAMA Sensei will be happy to make things clear for you. If you are interested to join the IGZIS school also, we can say that English-based programs also are available, so do not hesitate to ask for further information. Anyone is having a question? So maybe I'm having a question for OSAMA Sensei. Maybe a question can be asked why we are considering the iron as a material. For example, why not we're using copper or another metal for the nanotechnology? process?
This is one of the good question because there is many reasons actually behind that. One important reason is availability. Usually we look for the material which available. So as I mentioned in my presentation, the iron is the fourth available or abundant element in our earth. Then we can find the iron easy, and this is one thing. And this is, I mean, metal nanoparticles. So metal nanoparticle has several advantages, because one of these advantage is to remove those metal or magnetic particles from the water using the magnetic field. So iron can be easily removed by the applying magnetic field, and comparing with other metals like copper, silver, and so on, this may be the most cheaper one. And in the other side, the iron, when the iron, I mean, degraded or dissolved in the environment, is released the iron oxides, which also not toxic to the environment. Even iron, I mean, dissolved iron can be nutrients for probably bacteria, plants, even human. So there is no negative impact of the iron if it's under the control, of course.
Exactly. Thank you. Thank you very much, Sensei. So I think, yeah, we received so far two other questions. The first question, how much time does it take to decontaminate, for example, 1 liter of water? Is it an instant process? So we thank Amran San for the question. And what do you think, Sensei?
Yeah, this is another question. I think better to show this slide. Okay, anyway. Anyway, this is the slide I want to show what does not work. So this is the continuous treatment system, or the prototype of lab scale continuous system. So the Imran Sani question important. By designing this system, we can scale up and scale down this system based on the water resources volume. And by injection, the nanoparticle to this reactor, I mean the amount of nanoparticle to this reactor, we can remove. Anyway, the retention time, the time necessary to treat here is 20 minutes. So within 20 minutes, we can treat the specific amount of water. It's not 1 liter, it's the storage, or I mean the reactor size. So if this reactor 1 liter, then every 20 minutes we can treat 1 liter. If the reactor like 1,000 liter, then every 20 minutes we can treat 1,000 liter. So we need to design the reactor size depending on our requirement, and also the amount of nanoparticle to this system. So we can control the productivity. Yeah.
Thank you again, Osama Sensei, and thank for Amran San for his question and for his interaction. We received another question regarding the conference, Sensei. The Abdul Karim San asking about the conference, if it's online this year. So what about this year, Sensei?
Yeah, this is a nice question because I forgot to mention that. Thank you for this question. Actually, this is a hybrid conference. We have both physical and online. So you can join this conference either from your own country through the online, or you can join physically. So both available.
Yes, so do not hesitate to submit your manuscript by the deadline, July 31st. Yeah. Also, Abdul Karim San asking about, could we use that method to treat the surface water just like the underground water?
Yeah, exactly. So this is another question, maybe regarding to this system. This system is using for surface water. You can imagine this is river or lake. So we start the water here from the river. So in the groundwater, we create reactive zone, as I mentioned before, even by injection well, we inject the nanoparticles, or by constructing the permeable reactive barrier under the ground. So groundwater technique is different from the surface water. So surface water, we can use this system, continuous treatment system, starting from the river, for example, and when the water flow through this system, we can get the clean water at the end of the system. So for both nanomaterial and nanoparticles can be applied for both either groundwater or surface water.
So we still have time. If anyone is having another question for Osama Sensei, do not miss the opportunity to ask and to know more about these research field. In the meantime, I would like to mention again about the English-based programs available in the Chikushi campus and the IGZIS, because many students are interested to join asking about this kind of programs. Please check the website of the IGZIS school, the English-based programs, and you can apply for scholarship and join the WEEL laboratory, why not, and be one of the successful students working on this kind of research. So if anyone is having another question, you are very welcome. So I have another question, Sensei, just to make the idea more widen. What do you think, Sensei, about the applicability of this technology in real wastewater treatment plants, especially regarding the challenges of applying technology in real scale? Maybe it gives the students like further inspiration for research proposals.
Yeah, this is an important point because, as you know, we usually start the investigation of those nanomaterial with the different contaminant with ideal case. Just we select specific nanomaterial and one contaminants, because using this method or starting with this method, we can understand easy the interaction between this contaminant, for example, nitrate, phosphorus, arsenic, one single contaminant with those nanoparticles, and then we can confirm the mechanism of the removal. And this is very important for us. If we understand the mechanism, then we can, fabricate better nanomaterial to deal with that mechanism. And usually when we study that elements or that contaminants, we also investigate the interference with other contaminants, a group of contaminants. So of course, when we add several contaminants in the system, the efficiency will be decreasing because there is competition between the contaminants to achieve the nanoparticles, either adsorption, composition, or reaction, reduction, composition, competition between those nanoparticles. In this case, we have also to optimize the dosage for real application, because wastewater, as you know, is complex. It contains several organic matter and non-organic matter, and also nutrients, heavy metals sometimes, as well as bacteria and microorganisms. So all those environment or those community will interact with nanomaterial. So we also try to investigate the real wastewater or the really groundwater in our system. And usually we, as I mentioned, we start with the ideal case, then we apply the case which is close or very close to the real.
Thank you very much, Sensei. Well understood. Another question from Abdul Karim San. He's asking about the intake in the WEEL laboratory for a Master by Research program or PhD program. So he is interested to join the laboratory. And
so first, for Abdul Karim and other member, I put add in that, the chat box, the link of the WEEL, my laboratory, as well as the link of the IGZIS school. So in my my laboratory WEEL, you can visit the website and read more about the research topic and activities. And in the exits link, you can see about the admission process and maybe available scholarship, international program, and so on. Anyway, for Abdul Karim, we accept in WEEL both master and doctoral course. So actually, our school in Chikoshi campus is postgraduate school. We don't have undergraduate. So only master and PhD can join this school. So in my lab as well, we can only accept master and PhD student or doctoral student for this course. Actually, several students graduated from my lab and they working in several country or in several maybe university company. So it's both okay, master and PhD.
Thank you so much, Sensei. So good luck for everyone. And if you need any further support information, do not hesitate to contact the J-MENA project or contact us through Facebook, Instagram. We are doing our best to make the idea clear to all students. Also, if you are interested in watching the presentation again, we are glad to let you know that we are uploading the today's meeting on the J-MENA YouTube channel, also on the YouTube channel of the WEEL Laboratory. So you can attend the meeting again, you can share it with your friends and get more and understand more about this topic. So once again, if anyone is having question, do not miss the time. We are still having time. Special thanks again to Osama Sensei for his time and cooperation and supporting the J-MENA project. So still have time. I think so far, these are the questions we have received today. So thanks to our, okay, another question. Oh yeah, sorry, I missed this question. So Muhammad-san is interested to contact Japanese, means academic staff at Japanese universities. So he's asking what's the best or polite way to contact or to attract the attention of a professor. So making it work and working in the future. So what do you think, Sensei?
I'm not sure what's his intention. For example, Muhammad, he want to be a student, or he is, I mean, working in some university and he want to do collaboration. Based on that, we maybe different answer. But anyway, let us answer the student side. So you have to remember the professor here in Japan, including me, of course, we are very, very busy because Japanese university system make the professors too busy. And please, when you write email, very, very short email, just not more than 3 lines. Introduce yourself, your name, your country, your interest, direct to the point. And you can attach your CV as a PDF file. Then if the professor interested to your, I mean, interest, which you mentioned shortly in the email, then he will check your CV and maybe contact you. So please make short email, introduce yourself, your country, your objective, directly you want to join master course, doctoral course, and the research interest, and why you want to join this, I mean, group with this professor, and then attach the CV. If you want to apply for a scholarship, specific scholarship, you have also to mention that scholarship in the email. If you want to apply to the mixed scholarship, or if you have your own scholarship from your country, or you want to study based on your, I mean, budget, financial self, that you have to mention, because sometimes different, I mean, consideration based on the budget. Yeah, maybe that the easy and short way.
So yeah, he says arigatou gozaimasu, Osama-sensei. So I think by far we're getting close to end our meeting for today. So for those who are interested in more academic seminars, please join us in the next week. next Wednesday with another lecture with Kantor Sensei from Kyoto University. So the opportunities are very, so many. So do not hesitate to join, to develop your own research idea, proposal, and why not be one of the successful scholars at Japanese universities. Again, special thanks and appreciation to Osama Sensei. Thank you again.
You're welcome.
And thanks everyone for joining us today.